Hey guys, welcome back to the laboratory. In this video, we are looking at the relative formula mass. By the end of this video, you should be able to define the term relative formula mass, calculate the relative formula mass of different substances, and calculate the percentage mass of a particular element in a compound. So, let's go. The relative formula mass of a substance is the sum of the relative atomic masses of all the atoms or ions in its formula. Let's explore this concept by calculating the relative formula mass of carbon dioxide. Now, carbon dioxide consists of the elements carbon and oxygen, so we'll need the relative atomic masses for both of these elements to complete this calculation, and we can find these on the element symbols in the periodic table. Remember that the largest number on an element symbol will always be the relative atomic mass of that element. So, the relative atomic mass for carbon is 12, and the relative atomic mass for oxygen is 16. Now we can start our calculation. As there is only one carbon atom in carbon dioxide, and this carbon atom has a relative atomic mass of 12, the calculation for the carbon atom is 1 multiplied by 12. There are 2 oxygen atoms in this formula, and each oxygen atom has a relative atomic mass of 16. So the calculation for the oxygen atoms is 2 multiplied by 16. Finally, we add these two values together. 12 plus 32 is equal to 44. The relative formula mass of carbon dioxide is 44. Do note that there are no units for the relative formula mass, and so our calculation is now complete. Let's take a look at one more example. Now here, we have the chemical formula for aluminium oxide, which contains the elements aluminium and oxygen. Looking at the element symbols for both of these elements, we know that aluminium has a relative atomic mass of 27, and oxygen has a relative atomic mass of 16. We can now use these values to carry out our calculation. There are 2 aluminium atoms in aluminium oxide, and each of these atoms has a relative atomic mass of 27. So the calculation for the aluminium atoms is 2 multiplied by 27. There are 3 oxygen atoms in aluminium oxide, and each oxygen atom has a relative atomic mass of 16. So the calculation for the oxygen atoms is 3 multiplied by 16. Finally, we add these two values together. 54 plus 48 equals 102. The relative formula mass of aluminium oxide is 102. Here's a quick task that you can attempt to test your understanding of calculating the relative formula mass. Pause the video and take your time to work it through. Resume the video once you're ready to check your answers. Let's talk through the answer to question number 6. This is the formula for copper nitrate, which contains the elements copper, nitrogen, and oxygen. Looking at the information provided on their element symbols, we know that the relative atomic mass for copper is 63.5, the relative atomic mass for nitrogen is 14, and the relative atomic mass for oxygen is 16. Now we can use these values to complete our calculations. There is just one copper atom in this formula, so the calculation for the copper atom is 1 multiplied by 63.5. There are 2 nitrogen atoms in this formula, and so the calculation for the nitrogen atoms is 2 multiplied by 14. And finally, there are 6 oxygen atoms in this formula, so the calculation for the oxygen atoms is 6 multiplied by 16. Finally, we add the sum of these values together. The relative formula mass for copper nitrate is 187.5. Here are the answers to the other questions. So, how did you do on this task? Let me know in the comment section below. As well as calculating the relative formula mass of a substance, we can also calculate the percentage mass of a particular element in a compound, and we can achieve this by using a very simple formula. For example, let's say we wanted to calculate the percentage mass of oxygen in magnesium hydroxide. To achieve this, we would do 16, which is the relative atomic mass of oxygen, multiplied by 2, as there are 2 oxygen atoms in the formula. And we would divide this value by the relative formula mass of magnesium hydroxide, which is equal to 1 multiplied by 24 plus 2 multiplied by 16 plus 1 multiplied by 2. giving us a total of 0.552. We then multiply this value by 100, giving us an answer of 55 when rounded to the nearest whole number. Oxygen makes up 55% of the mass in magnesium hydroxide. Before we finish up, here's one more task that you can attempt to test your understanding of calculating the percentage mass of an element in a compound. Pause the video and take your time to work it through. Resume the video once you're ready to check your answers. Let's talk through the answer to question number 1. To calculate the percentage of aluminium in aluminium oxide, we will do 27, which is the relative atomic mass of aluminium, multiplied by 2, as there are 2 aluminium atoms in aluminium oxide. And we would divide this value by the relative formula mass of aluminium oxide, which is equal to 27 multiplied by 2 plus 16 multiplied by 3. We then multiply this value by 100, giving us an answer of 53 when rounded to the nearest whole number. Aluminium makes up 53% of the mass in aluminium oxide. Here are the answers to the other questions in this task. So, how did you do? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon.